Okay, so standard F-IF.C.7. So this is a long standard as far as there's lots of practice with graphs in this standard. So the first part says identify the vertex, give the minimum and maximum value of the function. So I can look up here. I know the vertex is always opposite of the inside, so it's +1. Keep the backside 1, 2. I look at my options, so I can cancel out option D. Option D is not correct. And then I have to read. I can see it opens up. So the graph opens upward, true. So the function has a minimum value of 2. This is referring to a minimum value is your y values. Please write that down. That is your y value when they give you a minimum value. That is correct. The function opens up and the minimum value has a y value of 2. Correct answer is A. After every problem, because we are going to reuse this information when we study for our AZ merit and for our district final exam in May. Esme, please stand back so you stay awake. Go ahead. Stand up. We're waiting for you.
Hurry up.
Go. Okay, going on right now to the second problem. Graph the linear equation, find the x and y intercepts. So what is the quickest way to do this? I like to do it this way. I'm going to just lightly cross this out, and now I'm going to solve. 3x equals 18. That means x is equal to 6. And now I'm going to go back and cross this one out, having 6y equals 18. Divide by 6, and y equals 3. I'm looking for an x-intercept of 6 and a y-intercept of 3. X-intercept 6, y-intercept 3. So let's start here. 6, so we're going by 1, 2, 3, 4, 5, 6. That is correct. And up 3. Correct answer is A. Flip over to the back side, please. Same concept here. Same concept for the third problem. You have 30 seconds working with your partner to get the answer. Begin. Correct option is B, has an x-intercept of 2 and a y-intercept of 3. Please do second plus 7, 1, 2 before we start the next problem. A rocket is launched from atop a 75-foot cliff with an initial velocity of 107 feet per second. The height of the rocket t seconds after launch is given by the following equation. Graph the equation to find out how long after the rocket is launched will it hit the ground. Estimate your answer to the nearest second. So let's circle that. When it says how long does it hit the ground, we're looking for the 0 or the x-intercept. Just as a quick reminder, what's another word we could use? Root or the solution, okay, often we refer to. So let's do second plus 7, 1, 2. Mine seems to be stuck. Let me grab a different calculator. We're going to go to y equals. I'm going to plug in the equation, -16. I'll replace the t with an x plus 107x plus 75. So I can see the answer is way over here. So let's just do process of elimination. Here's 1, 2, 3, 4. I know it's not this one. And I know it's not 0.6 right here. I can see it's way over here. 1, 2, 3, 4, 5, 6, 7. So it's right around 7. My only two options, which means it's going to be option A. I don't need to take time to actually calculate the exact answer and round it since they are not very close. Going on to the next answer. If I asked you, is this an even or an odd degree, you would say even. And is the leading coefficient positive or negative? It would be. Okay, with your arms, turn to your partner. What do your arms look like when you have a polynomial that is even degree and positive? It is up on the right and up on the left. Up on the right and up on the left. So look at your options here, because sometimes students can give this, but they have a hard time translating it into end behavior. Look at the options. Which one says as I go to the left it goes up, and as I go to the right it goes up? let's see here. As I go to the left, oops, that's not it. As I go to the right, nope. As I go left, nope. As I go right. Oh, you know what I'm doing? I'm so sorry here. I'm reading this wrong. Do you see how this particular problem has the y second and the x first? Does everybody see that? Yeah. It's backwards of how we normally write it. So here we go. As I go to the left, it should be going up. Can't be A. As I go to the left, it's going up. Good. And as I go to the right, it's going down. That can't be true. It has to go up both ways. As I go to the left, it's going down. No. As I go to the left, it's going up. Good. And as I go to the right, it's going up. Correct answer is D as in dog. Again, it flipped the order compared to how we normally write it. Graph the following equation on a calculator and estimate the local maximum and minimum. All right, you have 1 minute. Do second plus 7, 1, 2. You are going to have to probably adjust your window. I adjusted the y values to be the minimum y value to go down to -50 and the maximum to go to +50. And in doing so, I'm able to see the local maximum and minimum. So remember, I'm looking for the y values at this point and the y values down below. So the y value at the top is 31.62. So a maximum of 31.62. Local max 31.62. There's only one option with that maximum. I don't even need to worry about then calculating the local minimum. Going on to the next problem. This comes from the last unit we just covered, the very last unit. So when it's in graphing form, remember the bottom tells you what the vertical asymptote is, and the horizontal asymptote is in back, okay? So which one has a horizontal asymptote of y equals 3? That would be option A. Identify the zeros and the asymptote, then graph. So let's just identify, first of all, the vertical asymptotes. This breaks into x plus 4 and x minus 4. So I know that the vertical asymptotes are at 4 and at -4. So let's look at the options. Okay, that's good. Oh, can't be C. That's good, and it can't be D. So I'm eliminating things. In this form, because the degree on top is equivalent to the degree on the bottom, you can calculate the horizontal asymptote to be 2 divided by 1. So y equals 2 divided by 1 is horizontal. That's not A. That is option B. I don't need to go any further. Going to the next problem. Which graph matches the equation? Bless you. So I can see that it appears there is a vertical asymptote at 1, 2, 3, 4, 5. So vertical asymptote at 5. So I'm going to look in the denominator position. Which one of these would give you an answer of a vertical asymptote of 5? A or B? Let's cancel out C or D. And it appears there is a horizontal asymptote at right around 1. So which option gives you a horizontal asymptote of 1? Well, it could be A and it could be B. Remember, these are the same degree. Do you see how it's for both? It's 1. So now we're going to zone in on the 0 of the function. To find the zeros, or the x-intercepts, you take the numerator and you set it equal to 0 and solve. So this has a numerator of, has a 0 of 1, and this has a 0 of 4. So which one has an x-intercept of 1 or 4? Which option is it? X-intercept is 1. Correct answer is A. polynomial function that has the following zeros and has a leading coefficient of 1. Okay, so let's just use process of elimination. Okay, does this have a leading coefficient of 1? No. What about option C? Option B? Yeah. And option D? Yeah. Okay, by the way, how many zeros do we have? Look up above, how many zeros? Okay, that means we need to have a minimum degree of 3. Which one has a minimum degree of 3? Done. And you could check here, we could see that the zeros occur at 1, 2, and 4. All right, so notice that the number in front is a 1. What does that mean? It means that because the number is positive, our graph is opening upwards. So when you look at all the graphs, they're all opening upwards. I don't need to cancel anything out. This is also in factored form, which tells us that we have one x-intercept at -3 and another at +1. So I'm going to look now, -3 and +1. That's not correct. That's not correct. -3, +1. That looks good. -3, not a +1. Correct answer is B as in boy. Thumbs up or down right now if you're understanding this stuff. Okay, because it's fairly recent, right? Okay, we're going to go over here. So identify the vertical asymptotes. Remember that comes from the denominator. I factor this into what multiplies to equal 8 and combines to give us 6, x plus 4 and x plus 2. That means your vertical asymptotes occur at -4 and at -2. Correct answer is D. Okay, which of the graphs? So I'm going to give you, working with your partner, 30 seconds to decide which graph is the answer, and then I'll go over it. Ready? Begin. Vertical asymptote. So I want a vertical asymptote of 1. This does not have a vertical asymptote of 1. It can't be A. This does not have a vertical asymptote of 1. This does not have a vertical asymptote of 1. This does have a vertical asymptote of 1. I don't need to do any more work. Okay, correct answer is D. And I was able to eliminate the other 3 options by simply first finding the vertical asymptote. So I took the denominator, I set it equal to 0, and I solved. X equals 1 is the equation of the vertical asymptote. And when I looked at each option, the other remaining 3 options do not have vertical asymptotes of 1. This is the only one that has a vertical asymptote of 1. If we had to go further, because there was other options with a vertical asymptote of 1, we could also look and go, in this form, you can see that the horizontal asymptote is 1. Okay, we have that. And we could take the numerator and set it equal to 0. And we could see that the 0 is 2, which we have right here as well. Please go on to the next one. Graph the following and find the axis of symmetry and the vertex. So you may need a little refresher on this. As a reminder, here is the equation to find the axis of symmetry, -b over 2a. We did go over it this year, but it is a freshman level concept. So when I look, my a is 1, b is -3, and c is 4. So I'm going to substitute in -3 and 1. Two negatives, be careful, 2 negatives make a +3 over 2. So let's not do any more work. I know 3 over 2 is equivalent to 1.5. Let's look. This is not +1.5. Cross out. This is +1.5. It could be an option. This is not +1.5. This is not +1.5. I don't need to do any more work. Flip to the next page, please. Create a table for the quadratic function and use it to graph it. Remember that when it gives you instructions and it's multiple choice, you can do whatever method you want to get the right answer. So let's just do a few things to see if we can cancel stuff out. The leading coefficient is positive, and we're working with a quadratic function. Does that mean your parabola opens up or down? So cross out option B. All right, so what other things could we use? Well, remember in standard form, this tells us what the y-intercept is. So let's look at our 3 remaining options and see, can we cancel anyone out? So does this go through the y-axis at 1?
Yes.
It could be that option. Does this go through at 1?
Yeah.
Does this go through at 1? Okay, so it's option A or it's option C. Now, I want to go over a couple options you can do in order to get the answer. You can plug it into your graphing calculator right now. Is everybody listening?
Yes.
And once you plug it in, you can see which one it is. But here's even a faster option. So this will tell you your axis of symmetry. And if you've forgotten what that means, it means axis of symmetry cuts through the parabola and makes it symmetrical. So this one has a axis of symmetry that's negative because it's to the left of the origin. This one has an axis of symmetry that is? Okay. So x equals negative b over 2a. Is this final answer, all I want to know, is the final answer positive or negative? So which one is your correct answer? Correct answer is C, because it has a negative axis of symmetry. Remember, you could always plug this into the calculator and then you could match it to the graphs as well. So far, just curious, thumbs up or down right now, just what is your confidence level with what we've done? Okay, most of us are thumbs up. A swimmer is racing to the other side of the pool. The pool is 75 feet long. The swimmer travels 2.5 feet per second. Create a table, an equation, and a graph to represent the swimmer's distance to the other side of the pool with relation to time. When will the swimmer reach the other side of the pool? Okay, so working with your partner, I want you to start first examining the tables and seeing for accuracy which one looks right. I'm only going to give you 30 seconds and then we'll talk about it. Ready? Go. Esme, I'm going to choose you to help me, okay? So Esme, you ready? We haven't even started yet, but how far do I have to go to get to the other side? So how far is this swimmer trying to go? A distance of, okay, so 0 and 75. We haven't started, we have 75 to go. I'm just going to ask, instead of voices, you're going to raise your hands. Hands up high if you understand that fact. You have 0 seconds, 75 feet to go. Okay, now even though we don't see a 1, put a 1 up here. Esme, every second this swimmer travels how far? Okay, so can everybody take 75 on your calculator? Subtract 2.5. And you end up with 72.5. Now there's no 1 second. They're breaking this into even numbers, and that's okay. Let's go to 2. Let's subtract another 2.5. And now you're at, okay, now let's look at our options. This 2 does not go with 70. It's not going at the correct. This 2 goes with 70. It could be the option. Option B goes with 70. That could be right. Option D does not go with 70. So I have 2 options right now. Now let's look at the graphs. They both start at what appears to be 70. Oh, let's check. Let's go back here. They go 270. 465. So we have the exact same graphs. Now we need to turn this into equation. And they have different equations. So let's figure out which one it is. Do you see how this has a minus 2.5 and this has a plus 2.5? Yeah. Okay, we could do this in 2 ways. One, we could do it common sense. And the other way we could do it is we could do it using a calculator. So I want to show you the non-common sense way. Just please watch, don't practice. I hit stat and I edit. I type in what we see because we agree with this. 0, 2, 4, 6, and 8. Go to the opposite side, 75, 70, 65, 60, and 55. This is linear. We can see it's a linear line. So I'm going to go stat, calculate, and linear regression. And here's my answer. 75 and minus 2.5. So which one is 75 minus 2.5 is option? Now let's talk about common sense. This is your starting value. It's how much distance you have to go. For each time segment, which is a second, are you gaining on that or are you losing distance? And you're actually losing. And what I mean by that is even though you're gaining ground in the pool, you're losing the amount of distance you have until you finish, okay? So what I mean by is you're checking off how much distance you have until you reach the end of the pool. Correct answer is C. Flip over. Piecewise functions, one of your most favorite things from the last unit. Perfect is right. Okay, so let's first examine this. Remember that if there's no line underneath, it represents an open circle. If there's a line underneath, it means we include that point on the line and it has a closed circle. So I'm going to start with this. It says the line y equals -8. Okay, so I'm going to find -8. That means this line down here. So just so we can analyze this easier, I just highlighted them. Okay. So there's the lines y equals -8. So does this go through -8? Yes or no? And does it go all the way to +4? Now at +4, should it have an open or a closed circle? That does not have open. Cross it out. Does this go on the line y equals -8? Does it go all the way to +4? Is it an open circle there? This probably could be our answer, but let's keep going. -8, does it go all the way to +4? It sure does. Does it have an open circle? Is this on the line of -8? Okay, correct answer is C. Go to the next. We can determine the vertical asymptote by taking the denominator and setting it equal to 0. Nayeli, what is the the vertical asymptote? X equals 1. Okay, so I'm looking. X equals 1. Does this have a vertical asymptote of X equals 1? Yes or no? No. Does this have a vertical asymptote of X equals 1? So it could be this option. Does this have X equals 1? Does this have X equals 1? So it could be C or it could be D. We've eliminated 2 options. Remember, in graphing form, this represents your horizontal asymptote. Y equals -3. When I look at option C and I look at option D, only one of these has a horizontal asymptote of -3, and that is option C. Flip to the next. Okay, you ready? I think the fastest way to do this, because that's our goal, do second plus 7, 1, 2. Let's graph it. It does not appear like A or C or B. Correct answer is D. Go down to the next one. We're going to use process of elimination once again. Let's start with the top one. I'm looking for a graph that has the line y equals 3. That's a horizontal line. That horizontal line will only occur when x's are greater than or equal to 0. So this is a horizontal line. Do we have a horizontal line at y equals 3? No, they're trying to trick you. This is not horizontal, it is vertical. Cross out A. Is this a horizontal line at y equals 3? Now at the point x equals 0, is it a closed circle? Cross it out. I have 2 options left. This is the line y equals 3 as well as this one, and they both have a closed dot, so I can't cancel anything out. Now let's use common sense. When I look and I only have 2 options left, this parabola is opening up, this parabola is opening down. Look at your options here. Does this appear to be the equation of a parabola that opens up or down? Down, because the leading coefficient is, correct answer is D as dog. Okay, with your partner, you have a minute to get this problem done. Begin. Did you get it done, Riley? Was it pretty easy? Okay, so y equals 4. We only want it to occur where x's are greater than or equal to 2. Here's the line y equals 4, and it is occurring where x's are greater than or equal to 2, and it has a closed dot. This could be an option. Again, this is a horizontal line, y equals 4. This is not a horizontal line, y equals 4. This is vertical. They're trying to trick you. This is a horizontal line, y equals 4. It occurs where x's are greater than or equal to, because it's closed. This could be an option. This is the line y equals 4. It occurs where x's are greater than 2 but not equal to it. This would have to be closed. We can cancel out this option because it is not a closed dot. So between these two, I have a parabola that opens up or a parabola that opens down. So I look up here. This is a parabola that opens down because the leading coefficient is negative. That means the correct answer is B. We may have already done this problem or one very similar. So here we have a vertical asymptote of 1, vertical asymptote of 1. This does not occur at 1, I cross it out. This does occur at 1, it could be this option. Does not occur at 1, I cross out B. Does not occur at 1, I cross out D. My only choice, I don't even need to go into horizontal asymptotes or finding the zeros because I was able to cancel out every other option. Go down to the next one. Graph the absolute value function and label the axis of symmetry and the vertex. So remember, when I say y equals and then x minus 3, so we have an absolute value function that has been shifted to the right 3. So shifted to the right 3, there's no vertical shift. So this looks good. This is shifted the wrong way. I'm going to cross out C. Let's look and flip over the paper and find option B and D. Is it not there? It's not there, is it? Oh, got to flip to the very back. I'm sorry about that. Okay, this is not shifted to the right, it was shifted up. It was shifted in the wrong direction, and option D is shifted in the wrong direction. So we only have one option that is shifted in the correct direction, which is to the right 3 units. I don't need to worry about finding the domain and range because I was able to eliminate every other option. Okay, let's go on to the last one, which is a piecewise function. It's actually a step function. I know you have to flip around and find this. My apologies, they stapled it wrong. A shipping company charges $3.50 to ship packages weighing 1 ounce or less. Then they charge $1.50 for each additional pound, or a fraction of the pound up to 5 pounds. Write a piecewise function that gives a price for shipping a package weighing W pounds, then graph the function. So you have two options here on this page, and because it was stapled wrong, you're going to flip backwards and you have two options on the other page. With your partner, I'd like you to reread this and then start looking at your options. Go ahead. Okay, how many of you are confused right now? Okay, do me a favor and underline. I'm going to highlight this part. So it says that you'll pay $3.50 for anything that weighs 1 pound or less. So let me give you an example. 1 pound or less. If something weighs, Santos, if something weighs 0.1 pounds, how much do you pay? $3.50. If something weighs 0.5 pounds, what do you pay? $3.50. If something weighs 0.9 pounds, what do you pay? Now here's the tricky part. If something weighs 1 pound, what do you pay? $3.50, because it says you pay $3.50 if it weighs 1 pound or, so it can go all the way up to 1 pound, you pay $3.50. So look at this option. Option A says you pay $3.50 if it's between 0 and 1. Does it include 1 pound? Cross out A. Option C says you pay $3.50 if it's between 0 to 1 pound, including 1 pound. Is that true? Okay, let's go to option B and D and see if we can eliminate anything. Option B says you pay $3.50 if it's between 0 to 1.1 pounds. That's not accurate. Remember, it goes up to 1 pound, not past it. Option D says that we include 0 pounds, but we're not including 1 pound in the price of $3.50. So we've been able to eliminate 3 options, leaving only one option as the choice, which is choice C.